Okay, so what we have done so far, we have learned 3 different ways to solve systems of equations, also called simultaneous equations, also called linear systems, right? Kind of weird they have so many different ways of saying the same thing, but they do, right? They're special, right? But we have figured out 3 different ways to solve systems of equations. One was by graphing. We graph each one of the lines on the same graph and we look where they intersect, right? And we say, oh, that point where they intercept is the answer. Okay? Then we also realize, though, that graphing is often, in real life, they often don't meet right smack on that point. So it's good to figure out a method, an algebraic method, to be able to always find the answer. Because graphing will never allow you to always find the answer. You can sometimes find it easily, sometimes it's really, really hard. Then we worked on solving systems by substitution. With substitution, we had to have, one of the equations had to say what?
Y or X equals.
Y equals or X equals, right? And then we circled whatever that was, and we circled the Y and the other one, and then we substituted it, right? And then we found an answer to one of them, and then we plugged it into the original equation to get the answer to the other. Then we started with 2 equations written in standard form, where your x's and your y's are on the exact same side of the equal sign. Remember that? Standard form? And that was what your homework was last week, right? Whenever that was.
Thursday.
Yeah.
It was like last week.
Then it was
Right, that was your homework. And so that was, the process for that was magical, in my opinion. I just think it's totally amazing that you can take 2 equations, 2 separate equations, put a line underneath them, put a plus sign, and add them together, and immediately you've got your answer. Almost immediately you've got your answer for one of the variables. Right? And it would have been extremely hard. The one I did for the lecture would have been extremely hard to do that with substitution, right? So I'm giving you these different tools, and you are going to have to eventually learn how to choose which one is the best tool, right? And that's going to be the trick. Now, the problems I gave you last week on Thursday or whenever that was, were ones where you drew your line, you put your plus sign, and boom, you added them and it was done. However, now we're going to start making it a little more complicated. Today's is not going to be very complicated. Tomorrow's will be more complicated, right? Yes, question.
Are we going to do Khan Academy?
You mean the hour of code thing? Is that what you're talking about?
Khan Academy.
Khan Academy in general? Not today or tomorrow, but maybe we will this week. Maybe Friday or something. We'll see. So I'm going to give you a problem that's just a little bit more complicated than the one I gave you, the kind I gave you before. So here we go. We've got 4x. So write this down in your notes. Plus 3y equals 2. And then we have 5x plus 3y equals negative 2. All right. So has everybody written those down?
Yeah.
Now, if you use the technique I taught you last week, would that eliminate anything? If I tried to do this, if I tried my method last week that I taught, I draw a line here, I put a plus sign here. What's 4x plus 5x?
9x.
9x. What's 3y plus 3y?
6y.
6y. Uh-oh. Equals 0. That does not help me, right? Don't write that. Don't write this part in your notes.
Oh, we don't?
Scratch it out or erase it. Okay? But I'm just showing you it didn't help me. Remember, what is this process called? Elimination. Eliminate, right? It's like the Terminator. Like, right? You're trying to get rid of one of the variables, right? But we didn't get rid of it. So we have to do something different first before we add them together. So what do you guys think we could do?
Oh, plus 6y, and then switch the problem around so it's 6y equals 9x plus 0.
No, because that doesn't eliminate one of the variables yet.
But you could.
Wait. This guy had his hand up first. I wanna hear.
You could divide one of the variables. Like
Say more.
if you divide 3y by 3 and then negative 2y by 3. Would that take it away?
Okay, well, you're on the right track. I would say you're on the right track. But you're not quite there yet, but you're on the right track. Listen to what we were going to say.
Oh, I was just gonna say basically the same thing, but like, not that, but like somehow if you get that negative sign from the 2 and put it over by the 3y, like if
Wait a minute. So you're saying, you guys, tell me if this is what Lucinda's saying. She's saying that if that were a 3y, negative 3y,
you would cross them out.
then they would cross out, right?
Yeah.
How could I make that
You multiply it
a
by
negative?
a negative number, like
Moving it to the other side.
Say what?
Subtracting 3 on both sides, so it was move it to the other
Okay, that's a possibility, but then they're not underneath each other, and so I wouldn't be able to add them, right? So I want them to be.
them to the
So
same spot.
so wait, what did you just say, Lucinda?
Oh, you multiply each side by a negative number or something.
What do you think? What were you going to say?
Well, actually, is the answer negative 4 comma 6?
This guy.
Weston!
Negative 4 comma 6. I haven't a clue, but I'll tell you in a few minutes. All right. We'll have to see. But that's pretty impressive. All right. So I like Lucinda's idea. Before we add them, let's manipulate one of the equations, right? Manipulate them. It doesn't matter which one. You could manipulate the top one or the bottom one. But what I look at when I'm doing these is I look at the coefficients. What are the coefficients?
The x and y.
The numbers in front of the x's and y's, right? So 4 and 5 are coefficients, okay? 3 and 3 are coefficients. Wouldn't you agree with me that these are the same numbers right here?
Yes.
So if I could just change that sign, like Lucinda said, on one of them, then when I add them together, the y's would be eliminated, right? So that's what I'm going to do. So, and she had a great idea, to just multiply one of them by negative 1. But if I do that, I have to multiply the entire equation by negative 1, or just negative, right? I don't even bother putting a 1 there, because I'm going to just negative times 5x is negative 5x, right? Negative times 3y is negative 3y. Negative times negative 2 is positive 2. You see what I did? Whenever you multiply an entire equation by negative 1, all you're doing is changing every sign. Every sign in the equation changes to its opposite sign. If it's positive, it's negative. If it's negative, it's positive. Yes, Thorne.
In the beginning, I was being dumb and I thought that it was minus everything, and I got x. Isn't that right? Just x.
It will be, in this case, it will be negative x. But watch this. So now I'm going to rewrite this one down here. So I've got 4x plus 3y equals 2. With me? You with me?
Should we write this down?
Yeah. Now write this down.
Okay.
To the glory of the 4 year.
So this one is here now, right? I redid this one. I multiplied it out. I mean, it might have been better to just multiply it out over here and then rewrite this over here. But however, this is how I did it today. But then I brought this one back down because I have to be able to have them next to each other so I can add them, right? And would you agree with me? Now I could add them and I would eliminate my y's?
Yeah.
All right, so let's do that. We're going to get rid of that little. Okay, so we're going to add, draw my line. So what is negative 5x plus 4x?
Negative
Negative 1x, right?
Or just negative x.
And then, or negative x. And then we have this, which crosses out, equals 4. All right, it says negative x equals 4. I want to know what x equals. So, again, I want now that to be a positive x, right? So I can multiply, just like I did up here, I can multiply everything by negative 1, right? -1 times -1 is positive 1, x, equals -1 times 4 is -4. So x is -4.
Oh, Weston's on
You see how I did that? Did you write any of this down?
Weston OP.
All this has to be written down.
Gurry, Weston might be right.
Ooh, Weston.
Oh, wink,
Weston has
wink.
one.
Weston, I'm impressed. So far, he's right. Okay, now what do I have to do?
Plug it in.
Get the Y.
Plug it into what?
The first
Coordinate thing.
It doesn't matter. Either one of them. It really doesn't matter. But you wouldn't plug it into this after you've multiplied by -1. Really, you want to go back to the original equation. The reason why is because you know the original equation is right. And if you if you multiplied it right, it should work. But let's say you didn't. Let's say you multiplied by -1, but you forgot to multiply the -2 by -1. You know what I mean? So you really want to go to the original equation. That way you're sure, if it works, you're sure it works, right? So we're going to try it. So we have 4x. I'll just write it up here. 3y equals 2. And then I'm going to replace that x with that, right? I'm going to replace that. So my 4 times -4 plus 3y equals 2. So what's 4 times -4? Not 4 minus 4.
Positive 16.
4 times -4.
Oh! -16.
-16, right? -16, because positive times negative is negative. 4 times 4 is 16. Plus 3y equals 2. All right? Now we're going to have to, what do I have to do now?
Add 16 to both sides.
Add 16 to both sides because I want my y's to be alone.
It's going to be 6.
They want to be isolated.
Oh, Weston.
So we have 3y is equal to 18, right? We're going to divide by 3, divide by 3. Did you use this process, buddy?
No.
What did you do?
Weston.
He's got it. Let's give him a round of applause first. This is pretty impressive. What did you do? How did you do it?
Weston went to the
Yeah, come on up. I want to know what you did. This is awesome.
Yeah, okay. Where should I write it? Like just.
Wherever you want.
Okay, so, yeah. Where am I doing
Weston, I
this?
thought the pencil was your finger.
Okay. Okay, give me a second. I need to write this out in good handwriting. Okay, so 4. Okay, that's bad.
We use this one.
Yeah, good. Okay, so 4x plus 3y equals 2. And then instead of doing all that other stuff, I just minus 4x on both sides, like that. Yeah, there. Yeah. So yeah, give me a second. Okay, so 3y equals 2 minus 4x, and then another problem, 5x plus 3y equals -2. I switched out these this 3y for this right here, so 5x.
Oh, good
plus,
idea.
Oh wait, yeah, plus
Weston don't miss.
2 -4
Good thinking.
X.
So,
x plus 2 equals this was -2. So -2 minus 2 x equals x equals -4.
very
So,
good.
yeah, I
All
just,
right, very good. I get it. That's awesome. Round of applause. That's pretty impressive.
And it was
So-
birthday, Gary.
So, what is the method that he used? What would you call that? He used the substitution method. But instead of finding x, what x equals, he realized, well, if he could just figure out what 3y was equal to, then he could replace that whatever 3y was equal to, right? He found that 3y was equal to that. He circled that, and then he circled this basically, whatever, right? And he just plugged that in, right? So he used the substitution method. Now, do you understand this method? now?
I think so, yeah.
Basically, all we're doing is we're seeing that the numbers are the same, but the signs have to be different in order to add them to eliminate, right? So always look for the numbers that are the same first, right? The coefficients, right? Always look for those numbers that are the same. And if they're the same sign, you just multiply it by -1. And then everything in one of the equations. And then you just add them, right? Pretty straightforward.
Yo.
Questions? Does it make sense? You guys, fist to 5. You get it? Awesome. Okay, so I'm going to give you the homework now, and you guys can get started. All right?
Yeah.